Hey guys, this is a solution to the producer-consumer problem. In order to actually create the executable, you do the GCC command with the pthread flag set up, so it creates the object for us to execute the executable. As you can see, you just type in that in order to actually execute it. So the producer will create random items, and the consumer will consume the items randomly. And so, they'll keep on doing this in a essentially random period of time of simulation of the production of the items and the consumption of them. So that's what you see right now. Look over here, producer produced item 41, and the consumer consumed item 41. So it's using a mutex lock in order to actually sort of do this sort of functionality without the consumer essentially consuming something before it's ready to be consumed, or the producer sort of like essentially like there's a buffer of a certain amount of items that can be stored, and the buffer size is 10, and basically like there can't be more than 10 items produced. And so I'll show you some of the code in a second. So if we go over here, let's just start at the bottom here. Essentially, like, so here's the main. It creates the producer and consumer threads, and it waits for them to finish. Essentially, the producer thread will generate random numbers and add them to the buffer. The consumer thread will consume items from the buffer. So the way that the producer and consumer threads sort of like synchronize their access to the buffer is using mutexes and condition variables. So the producer waits for the buffer to have space before producing an item, and the consumer waits to have items that are available before consuming an item. And then they just basically run indefinitely until you Control-C and close the program. I just got this thing from the last assignment because I was like, I don't want to check if that error is happening. We import the pthreads library and these other ones that we need. Here's where we define the buffer to keep track of the state of this rapidly evolving state machine. And this is count of how many are available, how many are in, or how many are out. Here we define the mutex and condition variables. Like this basically means the thread is full, or rather the buffer is full. This means the buffer is empty. And so we define the producer function over here. So this is the producer function, and here we have the consumer function down here that consumes items from the buffer. This produces items and adds them to the buffer. So basically, this always runs. Generate this random number and add it to the buffer between 0 and 99, and then lock the mutex. You have to lock it before entering the critical region. And if the buffer is full, you have to wait for the consumer to consume some items before producing more. So basically, if the count of items in that buffer is equal to the max size, we basically use the wait for that. And we have the mutex lock, and we have the full condition, whether it's full or not. If it's not full, and so yeah. So if it's not full, then it will add, it will allow the producer to produce. If it's full, the producer will wait. So we insert the item into the buffer and update the buffer state variables over here. So this is the item, and the item over here, it generates that random number. That's what we're storing in that. And then over here, we increment the count by 1 because we added another thing to the buffer. This is basically just in the command line. You saw the producer produce an item, and the item was that specific number, that integer value. Here we have to signal to the consumer that the buffer is no longer empty. So this is that condition. Like, is it empty? Yes. Is it not empty? So then we can unlock the mutex with the pthread mutex unlock, and then it allows the consumer to access the buffer. So when the buffer is not empty, then the consumer can access the buffer. And we sleep for basically a random period of time, and that allows us to simulate the production of the items. So down over here, we define the consumer function. So this one is eating the products of the producer. Of course, we have an item, of course, just like we have here. And the consumer thread keeps on running, and similarly, we lock the mutex before entering the critical region. And if the buffer is empty, we need to wait for the producer to make some more stuff. Then we have this pthread condition-based wait, whether it's empty or not, and that mutex reference to that mutex lock. And so over here, the logic is slightly different. We're trying to remove the item from the buffer and update that buffer state variable, and then decrease the count, of course. Then this is all the prints you saw of the consumer consuming the item. We have to signal to the producer that the buffer is no longer full. So, we ate some stuff. Then we have to unlock this mutex, so then the producer can access the buffer. Because if it's not full, then it should be able to access it. And then we sleep for a random period of time to basically simulate the consumption. So the production and consumption are randomly sort of generated at a specific time. We create a producer thread and a consumer thread, and we wait for them to finish. We can seed whatever the random number generator uses with the current time, and we can create the threads that we defined over there with the type over here. And so the pthread create, that is what we use for that. And then we can wait for the producer and consumer threads to finish over here. Then we can exit the program. Although these threads will just keep going indefinitely. And so, yeah, it never finishes. Then you can run it. So that is pretty much an overview of this. I'm going to add the YouTube link pretty soon for the video you're watching. I hope you enjoyed the video. Have a good day.